Tomorrow, you have a test on Chapter 9. Chapter 9 is 7 sections long, and with all of our disruptions to our schedules, we've been in it for a while. You've learned a lot of theorems, or I guess I should say we've seen a lot of theorems, and tomorrow we'll see how well they've been learned. But there are a lot of theorems and rules in this chapter. So I always encourage you to study. I really, really encourage you to study for this test tomorrow, because there are a lot of rules and properties here. I'm not going to walk through every single one of these theorems and just read them out to you. They're the same as within the notes, and you have all the pictures and diagrams that we've drawn within the notes throughout. If you missed any of those, all the videos are online as well, so you could go back and look at those. Some things I do want to point out here, and then we'll do some examples. You need to know definitions to be able to locate things within a diagram, not to be able to write definitions. So given a diagram, locate a chord, locate a secant, locate a tangent, locate an inscribed angle, to be able to find them and name them appropriately using proper notation. So if something's a segment, we need it to be a segment. If it's a line, we need it to be a line. An angle needs an angle. Okay. So definitions you do not need to be prepared to write out, but to be able to locate those things within a diagram. Then we have a lot of theorems that we're going to use to apply to solve problems. And they're written here. Probably more helpful to go back to your individual notes so that you have the diagrams to put pictures to the words of what all these say. Practice, practice, practice. So we're going to practice here together. This is in your packet. I would suggest that you do take notes as we do this, but possibly on a separate sheet of paper so that this will still be blank, and then you could give it another try by yourself tonight. Because it doesn't matter if you can watch me do it or if it even makes sense when I do it. It matters whether you can actually do it. And in the other class today, I actually just said, you know what, I'm not even going to go through it. Just go ahead and work on it. And we all started to realize how much has been forgotten. So I'm going to walk through it with you, but I would suggest maybe doing this on a separate sheet of paper so that you have a blank copy of this, and then you can practice again later. I'll also show you a place in the book where you can find some problems to practice again, some different stuff tonight. The first group of questions is looking for definitions, and this is the locating things within the circle. We don't need to write out the definitions, we need to find them, and we need to use proper notation. So where's a chord that is not a diameter? DC as a segment. Okay, we need that symbol above it. CD, DC, same thing, doesn't matter which letters you do. But we want those two letters, and we need the symbol for a segment above it. A diameter, where's a diameter? AD. AD, again, the order of the letters doesn't matter, AD or DA, but we do need the segment symbol above it because a diameter has ends. A radius.
OC.
OA, OD, OC, those would all be possibilities. They are all segments. It doesn't. A tangent. AB, and a tangent is a line. So we need the correct symbol above it. A secant.
OB.
One that's drawn in the picture. DB or BD. Doesn't matter which order. You could also call it CD. Okay? It doesn't matter which letters we use along that line, but we want to take two letters from that line and make sure that it is a line above it, because a secant extends beyond the circle forever, whereas the chord is contained within the circle, so it gets the end points. There's only a few here. Any definitions we've had would be fair game for trying to locate something. So another thing I could ask you to locate is, for example, an inscribed angle. There's an inscribed angle. An An inscribed angle would be angle ADC. An inscribed angle has its vertex on the edge of the circle. Okay. We had a lot more. We had central angles, we had minor arcs, major arcs, all of those things we think you should be able to locate within a circle and name with appropriate notation. The next group of problems goes into actually solving some problems involving angles and arcs. We had 5 different types of properties that we're going to look at in these for angles and arcs. A lot of different rules and theorems to keep track of. AOB, angle AOB. First, as a definition, what kind of an angle is angle AOB?
Central.
A central angle.
Oh, yeah.
Okay. A central angle has its vertex at the center. O is the center of this circle, so angle AOB is a central angle. Now to find out how big it is, how big is a central angle?
Half of its arc.
The same as its arc. So how big is AOB? 120. Okay. A central angle is equal to the arc it is across from. ADB. ADB is what kind of an angle? Inscribed. And what is our rule about the size of an inscribed angle? Half of the arc. So it is half of that 120, means it is 60. ACB. Angle ACB is an angle that is formed outside of the circle. What is our rule about an angle formed outside of the circle?
Subtract the 2 arcs.
And
Multiply by half.
it's 1/2 the subtraction of the 2 arcs it cuts off. So angle ACB cuts off 2 arcs. It cuts off the arc from A to B that's labeled 120, and it also cuts off the arc from A to B around the other way. How big is that? The other part of 360. So the whole circle is 360. If there's 120 on the inside of that angle, subtract from 360 to find that there is 240 on the outside of that angle. And this is going to be 1/2 of 240 minus 120, which is 60. Now be careful, in this particular example, it happened to just be half of the arc that was right next to it. This is one special specific case where that's true. It is not true in any other case. Okay? For any other number other than 120, that would not be true. So it's not just half of what's close to it, it's half of the difference of the 2 arcs.
Does it matter in which order when you're subtracting them? You put the outside angle minus the little angle?
We want to put big angle minus little angle. Okay. So that we get a positive answer. EAD. EAD. Okay, so EAD is formed by a, what is EA? Tangent, and AD is a chord. An angle formed by a tangent and a chord is how big? Half of the arc that it cuts off. So it cuts off the arc from A around to D. So how big is that arc going to be? 200 degrees. So from A around to B, we said in the last one in green there was 240, and this one stops 40 degrees before that. So from A around to D is 200 degrees, and our rule for an angle formed by a tangent and a chord is that it is half of its arc. An angle that's formed by a tangent and a chord is half of its arc. The arc that goes around from A to D would be 200, so that along with the 40 and the 120, we would get a 360. So half of that 200.
Same rule as the
Same as an inscribed angle. Same rule again with half. Halves come up in a lot of our rules. We've got an angle outside is half the difference. We haven't seen it yet, but an angle inside is half the sum. An inscribed angle is half of its arc, and the tangent and chord angle is half of its arc. One that we don't do a half for is the central angle. The central angle just is its arc. Okay. The next, starting at question 10, we move down to the next picture, but I want to ask one more question about this picture before we go down to that next group. And I want to ask, how big is angle OAC? What kind of thing is OA?
Radius.
A radius. What kind of thing is AC? A tangent. What is true about a radius and a tangent?
Perpendicular.
They are perpendicular, so they make a 90-degree angle.
What's it?
Hmm? So far we've had 4 different types of angles we've encountered. Radius and tangent, perpendicular. Chord and tangent, half of arc. Inscribed angle, half of arc. Central angle is arc. Oops, I guess we've had 5. Outside angle is half of the difference. Okay? 5 different rules so far. Lots of rules to keep straight. The best way to keep them straight is to practice them. Number 10, we're jumping down to the next picture. If AEB, this angle is 20, and AFB, this angle is going to be how big?
20.
Why?
Similar.
What kind of angles are they? In a circle. Inscribed angles. They're inscribed angles. Their vertex is on the edge. The vertex is either E or F. They cut off the same arc, so they would have to be the same size. How big would that arc be? 40. An inscribed angle is half as big as its arc. So if this inscribed angle at E is 20, the arc would be 40. And if we bring that back to a different one at F, it's still going to be half of that arc. If arc AB is 95 and EF is 25, AGB, the angle outside, what's our rule for angle outside?
It's the sum, or it's a difference.
Half of the subtraction, or the difference. Okay. Angle outside is half of the difference of the arcs. Next one, if AB is now 70 and EF is 30, then AHB, an angle inside the circle, is what? What is our rule here?
50.
What's our rule here? You were giving the right answer, but how do we find that answer?
You add in the
You add
Half of the
Divided
sum
by 2.
of the two. Okay. Angle outside, half of the difference. Angle inside, half of the sum. So we get 50. If arc AB is 85 and angle EHF is 59, then how big is arc EF? This is the same kind of problem as the last one. We're dealing with an angle inside, but this time we know the angle and we want to find the arc. So we have to work backwards and do some algebra. Our rule is an angle is half of the sum of the arcs. So the angle 59 is half of adding together the x and the 85. Multiply both sides by 2 because that'll cancel out that half. So 118 is equal to 85 plus x, so we're going to subtract that 85. Find 33. That's our answer. Individually, day by day, these problems haven't been so bad because we'll have 1 or 2 or maybe 3 rules in a lesson. We've now seen 7 different rules about angles in these problems. So knowing which rule to apply when is a challenge. Okay?
How many points is this test?
75.
It's a test.
It's a test. 75. It's over 7 homework lessons, and typically your tests match your homework. So it's been 70 points of homework, 75 points. Our rule for an angle inside is that an angle inside is equal to 1/2 the sum of the 2 arcs. So 59 is equal to half of the x plus 85. So we solve it algebraically by multiplying both sides by 2 and then subtracting.
We get some
One more time, how do you decide 10 and 11? How do you decide to subtract or add?
11 and 12, you mean?
Yeah, that's it. No,
yeah. On 11, guys. On 11, the angle AGB was outside of the circle. Outside our rule says subtraction.
This is Sarah. Can you send Abby Bradley to the office?
Yes.
Thank you.
And on number 12, the angle we were looking for, AHB, is inside the circle. Inside is half the sum.
Okay.
Outside subtraction, inside adding. All right, I'm going to scroll down and we'll complete the last group of problems here, but I'm going to lose all this writing. So are there any more questions before all this writing goes away? For number 14, we're looking at the lengths of these pieces within the circle. I will tell you the most common wrong answer to this question or a question like this would be 4. Okay? Many students want the chords to be the same size. So we can say chord CD is 9. Okay, let's make chord AB be 9. Okay? Not all chords are the same length. Some are closer to the edge and they are smaller. Some are bigger and closer to the center like the diameter. So they are not all going to be the same size to just subtract and find how big the missing piece is. But last night we had a rule. What can we do with those pieces?
6 times 3 equals 5 times.
We can multiply the pieces together. So 6 times 3 equals 5 times x. So 18 is equal to 5x, and x is 18 fifths. Or 3.4 if you prefer. 3.4 would be fine. Okay, oh no, 3.6. Whatever it is. The decimal would be fine. I just leave it as fraction. Number 15 is secants. What was our rule for a secant? The whole times the outside. Okay? Never just the inside alone. The whole times the outside. So for this bottom one, I'm going to do 8 times 3. For the top one, what is the whole length?
X 2 plus X.
X plus 2 or 2 plus x. Doesn't matter what order you do it, but it's not just 2x. Okay? We're adding those together. So 2 plus x or x plus 2 is the whole length times the outside is 2. Solve this. We multiply and get 24, and we distribute that to 2x plus 4. Subtract the 4, and we get an answer of 10. Number 16, we have a secant again. So for that secant, we want to take the whole 13 times the outside 4. Then we have a tangent. What do we do with a tangent?
You double it, or you square it.
Square it. And we want to multiply things, and a tangent only has one piece, so we just multiply it by itself. That's what squaring is. So when we multiply this together, we get 52. 52 is not a perfect square, so when we take our square root, we then want to simplify and look for a perfect square that divides into 52, which is 4. We were there just a minute ago. 4 times 13. And the square root of 4 is 2. So 2 squared root of 13 is the best form of that answer. (17) We're told CA and CB are tangents to the circle. What does that mean about CA and CB? They are congruent. Tangents to a circle from a point are congruent. So since they're both from point C, they are both going to be 12. We are looking for X, that line that goes through the middle there. I see a triangle in the picture, triangle OAC. What kind of a triangle is it?
Right.
A right triangle. A radius and a tangent are perpendicular to each other. So this is a right triangle. How can we find a missing piece in a right triangle? Pythagorean theorem. 5 squared plus 12 squared equals x squared. 25 plus 144 is 169, which has a square root of 13. Yes?
Why can't you just square root everything at the beginning?
You wouldn't get the same answer.
Whoa, what is this
You
about?
get 17.
Whoa.
It doesn't work. It's an order of operations problem.
Why is there
We're not going to do it. Chill out. Chill. Chillax. I strongly urge you to try these problems again on your own. And or in your book from page 369 to 371 are chapter review and chapter test questions. That might be a good way to study too. I'm sure some answers in the back, I don't know if all are just odds, but you can check that out, and that would be a good way to study and practice as well. I don't want to scare you, but I want you to understand that this is probably going to be a hard test because there are a lot of theorems here, and it's a lot to keep straight. And the more you practice, the better you're going to be at keeping straight which theorem to do when. So practice this again, or practice the chapter review and test questions from the book. But somehow, please practice and study.